We present an interactive explainable of generative neural networks, a popular image synthesis technique. The explainable centers around a cohesive narrative that builds an engaging analogy between GANs and a story about cats, dogs, and wizards. Gandalf and Diophantus are fictional characters that represent two networks in a typical GAN architecture. The generative and discriminative roles that they play are portrayed as magical powers of generating dog-looking cats and identifying fake dogs, respectively. The main story is about a cat who wants to join a dog-only Halloween party, which is guarded by Diophantus, the discriminative wizard that identifies dogs. The cat goes to Gandalf, the generative wizard, for help. After introducing the story, we explicitly make the connection to image synthesis task and the story, identifying analogies between the characters and the components in GANs. To give an overall picture of the story and hammer home the connection with GANs, we present a video of the storyline with a transparent overlay that shows the architecture of a typical GAN. The next page discusses more technical details about GANs after the reader has absorbed the context. The more abstract diagram is still annotated with arts that remind the reader of the story for better coherence and context. To make the connection to the real world and show the growth and impact of this technology, we present a more traditional data visualization of 500 highly cited GAN-related papers over the years. The y-axis is time, and y-axis is the paper categories as marked in archive. Each dot represents a paper, along with interactive tooltips and links to the paper once clicked on. Now that the reader knows a bit more about GANs, they can start playing around with one to explore its capabilities. In this interactive widget, we show 3 random samples of the output of a 512 by 512 big GAN given an input of dog classes. We provide all dog classes labeled in ImageNet. The Alaskan is our favorite. One of our team members has one of them at home. His name is Boo Boo. The next widget further connects to the earlier story by allowing the reader to morph from a cat to a dog, given the desired weight. We provide a constrained yet interactive way to start exploring the space of possibilities provided by GANs. This also serves as a prelude to the next discussion of latent spaces, a central concept for the interpretation of GAN outputs. The final page shows 100 random samples of the same class of dog projected onto a 2D plane using principal component analysis. The goal is to give the reader a hint about the image generation process and the inner workings of GANs. By directly showing the output images in an interactive way, we hope the reader can make his or her own interpretations of how the outputs relate to each other and build an idea of what a latent space is. This is still an ongoing research area with a lot of exciting research questions to be answered.